write in the chat box if you can hear me. Hello. Can you hear me, students? Okay. Okay. Fine. Sapam, journal wins. Okay. Yes, ma'am. Okay. You can hear me. Fine. Okay. So, um, can anybody remind me what did we do in our last class? What did we do in our last class? Can anyone please remind me? I forgot. You might have written in your copy the topics. So, what was the last topic that we discussed? Anyone? Sedimentation aided with coagulation. Okay, okay then. Sedimentation aided with coagulation. Have we discussed about the coagulants, or just we have discussed what is sedimentation aided with coagulation? Did we discuss all these chemicals? You can see my screen, right? Just see and tell me. Have we discussed about all this?
Yes, ma'am.
Use of chlorinated copperas, all these things we have done, right? Numerical also we have done one numerical. This numerical have you done? Determine the quantity of alum. Quickly check if you have done this numerical. No. Okay, so that means we have done up to here, right? Use of sodium aluminate as a coagulant. Am I correct? Yes or no? Up to point number 4 we have done. Okay. Journalist said yes. Okay. Okay, fine. So today, so you have known about the coagulants. So today we will be doing one numerical related to your coagulant. Okay. So let us see this. See this question. See, determine the quantity of alum required in order to treat 13 million liters of water per day of a treatment plant, where 12 ppm of alum dose is required. Also determine the amount of carbon dioxide gas which will be released per liter of water treated. Okay, so here in this question it is said that to find the quantity of alum. Okay, alum we have learned already as a coagulant, right? So we have it is given to find the quantity of alum. Okay, that is required to treat a treatment plant whose quantity of water is 13 million liters per day. Okay, and where 12 ppm of alum dose it is required. Okay, so and also what is the amount of carbon dioxide gas that is released, okay, per liter of water treated. So as you see this question, so you should be able to know that yes, for alum coagulant there is one equation, right? So you have to, that's why I was telling that for the equations, chemical equations are important. You have to remember the chemical equations, okay? So first, let us see that what it is given in the question. The quantity of water to be treated, it is given as your 13 million liters per day. Clear? Then what is next given? It is your alum dose. What is the alum dose given? It is 12 ppm. What is ppm? ppm is your milligram per liter. Already we have studied all this, right? So then we need to find out that how much of amount of alum it is required per day. Okay, so if we multiply your quantity of water and the alum dose that is given, then you will get how much of alum or amount of alum is required per day. Okay, so you need to multiply first the quantity of water and the alum dose required. Clear? So here after multiplying, it was in milligram, but they have converted to kg. So it is 156 kg. That is your the first part of your answer. Okay, the first part of your two parts are here. No, this part is one part, and the second part is the find out the carbon dioxide gas. So the first part of your answer is very simple. Just you need to multiply both your quantity of water and the alum dose. Clear? So next is your need to find out the amount of carbon dioxide gas. So how will you find out the carbon dioxide gas? By you know that we you know the equation of alum. So okay, what was the equation when you add alum to your water? So this equation you already got. You need to remember this equation. Okay, the balanced chemical equation. Then since it is told to find out the carbon dioxide gas, okay, and the amount of alum, so first we need to find out the molecular mass for your alum. Okay, this is your alum formula. Okay, aluminium sulfate. So this part we will first find out the molecular mass. And for molecular mass, this one you have to remember your class 12 chemistry. Okay, so we that time we have done all these things, right? So for aluminium, what is the molecular weight for aluminium? It is 26.97. Okay, it is given in your decimal, but somehow we remember it to be 27. So you can write it to be here 2 is there, correct? Is Al2. So 2 is here. So 2 into what is the molecular weight for aluminium? It is your 27 plus your what is the sulfur molecular weight? It is 32. Correct? 32. It's given 32 here plus your of 4. Here it is oxygen. There are 4 oxygen. So 4 into what is the molecular weight for oxygen? It is 16. Correct? So here it is 4 into 16. But the whole thing, this SO4, it is whole, it is multiplied by 3. So here it is 3. Okay. Then again plus 18 H2O. H hydrogen everyone knows it is 1. Okay. And oxygen it is 16 again. So like this you need to find out the molecular weight. If you have forgot how to find out the molecular mass, then please refer to YouTube or you can refer to your class 12 chemistry book. Okay. Again, like similarly, you need to find out the molecular mass for your carbon dioxide. Since in the question it is told to find the amount of carbon dioxide. Therefore, we need to find out the molecular mass for carbon dioxide. Okay, so the molecular mass for carbon dioxide, it is they got it to be 6 into 44. Okay, 44 they got CO2 value is 44, but since here it is balanced chemical equation, 6 is here, so they have multiplied it by 6. Okay, so the line you should write like this. Now it means that 666 milligram of alum. Okay, 666 here you got amount of alum. So 666 milligram of alum if used will release 6 into 44. Okay, 44 is the CO2 molecular mass, and since here it is the 6, so it is 6 into 44 milligram of carbon dioxide gas. Okay, so now you do the military method. Unitary method you do. Unitary method, when you do, you can easily do the unitary method like, therefore for 12 milligram of alum, it is already mentioned in the question that 12 milligram of alum it is required. So 12 milligram of alum will release 6 into 44 divided by 666 into 12. Okay, that is a unitary method. So finally the answer is 4.76 milligram. Okay, so the answer, finally the answer is 4.76 milligram. Okay, this is not a very tough question if you can remember the chemical equation and the, you know, how to find out the molecular mass, then it's not a very tough one. Okay, and then you have to finally do the unitary method. That is a very simple one. Okay, then do it in your copy. This one, I guess I have shared with you in WhatsApp, this PDF, right? So you note down this numerical in your copy. Okay, then only you can remember, otherwise you will forget. Okay, and okay. So coagulant part we have finished. Okay, with this numerical we have finished the coagulant, that is sedimentation aided with coagulation part we have finished. Now next we proceed to our filtration. Okay, we will proceed to filtration. See, it is like that you have done plain sedimentation. Okay, then after plain sedimentation you have done sedimentation aided with coagulation, right? So basically, you see, you might ask me that, ma'am, why, if plain sedimentation is done and after that again sedimentation aided with coagulation is done, and you already told that the very minute particles or the minute suspended particles that remain floating in the water, though by coagulation, by adding coagulants, those things they settle down in the sedimentation tank. Okay, up to that it is fine, but is that the end of your treatment process? No, because after adding the coagulants also, okay, there are, there are very minute particles, very minute suspended particles present in that water that still keeps floating in the water, and also there are bacterias. Okay, there are bacterias, and you can say there are, turbidity is there, color is there, odor is there, isn't it? And there are pathogenic bacteria also present in that water. Okay, so we cannot supply that water to the public like that. Yes, even though you have removed some of the, very minute particles that kept on floating in that water, and by adding coagulants, but after adding coagulants there will be some, there will be some odor, there will be some turbidity, again there will be some color, and most importantly there will be pathogenic bacteria present in that water. Okay, so we need to, these all these things, okay, these especially the pathogenic bacteria and pathogenic bacteria, they can be removed by your filtration process. Okay, and filtration process, I guess everyone knows, because in your home also you can see what are the filter materials that are used in your tank, right? So basically for your filtration process, we use, what are the filter materials that we use are gravel and sand. Okay, these two are the most important one. So here you can see from here, screening and sedimentation removes a large percentage of the suspended solids and organic matter present in raw supplies. The percentage of removal of the fine colloidal matter increases when coagulants are also used before sedimentation. But however, the resultant water will not be free from impurities and may contain some very fine suspended particles, okay, and bacteria present in it. Okay, To remove or to reduce the remaining impurities still further and to produce potable and palatable water, the water is filtered through the beds of fine granular material such as sands. Okay, so the process of passing the water through the beds of such granular materials is known as filtration. You can write the important lines from here. Okay, what do you mean by filtration? You can write it from here, correct? Okay, so now let us see what are the types of filtration. Okay, sorry, before that let us see the theory of filtration. Okay, there are some theories behind your filtration, so let us see the theories. Okay, first one is your, let me draw one thing. Just wait. G is your gravel, okay, and S is your sand. Okay, so suppose this is our filtration unit. Okay, so let us see first of all what is the theory of filtration. Number one is your mechanical straining. So what it is written here, the suspended particles present in water and which are of bigger size than the size of the voids in the sand layers of the filter cannot pass through these voids and gets arrested in them. The resultant water will therefore be free from them. Okay, so the water which is coming in contact in this our filter unit. Okay, so the water which the water which is going through the filter unit like the sand or gravel. So in that water, the impurities that is contained in the water, if the size of the suspended particles present in the water, it is the size is bigger than the size of the voids. Okay, in the sand there are voids like this. Yes, you have studied in soil mechanics, right? There are many voids. So if the size of the suspended particles that is present in water, it is larger, it is bigger than the size of the voids in the sand layers, then what will happen? Obviously these suspended impurities, they cannot pass through these voids. Yes, when you will pour this water here, this the particles, it will get strained here in the above. Okay, it will get strained in the above layer of the sand. Okay, so these particles, this will form a mat, you can say a mat in the upper sand layers. Okay, so like this the impurities are strained, so this is known as your mechanical straining. And this layer, okay, this layer that is that has strained in the upper layers of the sand, so it can be removed by your mechanical straining. Clear? So next is your flocculation and sedimentation. So here it is the sizes which are the suspended particles that are present in water. We have in mechanical straining what it is written that if the suspended particles present in water, it is greater than the size of the voids of the soil. Okay, but in flocculation, what it is given that the size which are the suspended particles, the size which are less than the size of the voids. Okay, in mechanical straining, the size was greater when the size of the suspended particles are greater. But in flocculation and sedimentation, what happens to those particle sizes that are smaller than the size of the voids of the soil? Okay, so if the size is small, then obviously the water, it will penetrate the particles, it will penetrate to the penetrate in the soil, isn't it? It will penetrate to this layer, it will come to this layer. Then if it comes to this layer, what will happen? It since you know that the impurities, they are gelatinous precipitate. Okay, they are gelatinous, they are somewhat like sticky. Okay, so what they do when they penetrate through the soil, okay, when they penetrate through the soil, they will attract the particles besides it. Okay, So they will the particle, it will attract the other fine particles that is present within it. Okay, so what will happen after the same procedure for coagulation will happen. Okay, so when it attracts the other fine particles towards it, so it will become a heavy particle, and then it will settle down and you will get a clearer water. Okay, so that is the theory behind your flocculation and sedimentation here. And now the third one is your biological metabolism. Okay, so in your bed, okay, filter bed, there are bacteria, or you can say there are bacteria present. Okay, in your filter bed your bacteria are present, but these bacteria, they need, okay, they need all some food for their survival. Okay, they cannot, everyone needs food for their survival, isn't it? So as the bacteria, they also need some, food for their survival. So what are their foods? Okay, the water that is, that is going through the filter bed, that water it contains, okay, some planktons like algae. Okay, planktons it contains, then algae it contains, some green plants it contains. Okay, so all these things, those organic impurities, okay, that are present in that water, the, these certain, these microorganisms and bacteria, they rely on this planktons or algae or organic impurities. Okay, they take them as their food for their survival. Okay, like that also, your, if they, these bacteria, they consume these foods, these planktons and algae and all these things, so what happens, the water it becomes clearer. Okay, so biological metabolism is about the bacteria that consume thus algae and plankton, all these things. Okay, so next is your electrolytic changes. Okay, it's not changes, it will be charges. Okay, electrolytic charges. So what it is written here, you see, the purifying action of filter can also be explained by the theory of ionization. According to this theory, a filter helps in purifying the water by changing the chemical characteristics of water. This may be explained by the fact that the sand grains of the filter media and the impurities in water carry electrical charges of opposite nature. When these oppositely charged particles and the impurities come in contact with each other, they neutralize each other. Okay, so suppose this was your sand bed and this one was your gravel bed. Okay, so when this, the sand bed, okay, the upper layer of the sand bed, they contain some charges. Okay, they contain some charges, and the water that you are pouring into them, or the water that is the impurity water that is coming in contact with the sand bed, it also, the water also contains some charges. Okay, so these two charges, this the water, the impurities that are coming in contact, and also the sand voids. Okay, so those two are containing opposite charges. Okay, those two charges are opposite in nature. So when these two, oppositely charged particles, they come in contact with each other, so what happens, they neutralize each other. Okay, they neutralize each other, and when they neutralize, they change the character of the water, and it makes it purer. Okay, so oppositely charged impurities, they come in contact with each other and they neutralize each other, and as a result what happens, they change the characteristics of the water and makes it purer. Okay, and what happens like this, after a certain interval, you can say that the charges, okay, of the sand bed, what happens, it gets exhausted. Okay, it gets exhausted, it gets depleted, and so what, we have to restore again the sand bed by, again you can pour new sand, or you can clean the filter. Okay, like that you can restore the electrical charges. Okay, so this is all about your theory of filtration. Then next is your filter materials. Filter materials, already I told that about sand and your gravels. Okay, so there are certain properties of what kind of sand you should use. Okay, so there are certain properties that you have to use this kind of sands. Okay, so let us see what are the properties for the sand. Number one is your, it should be free from dirt and other impurities. Okay, then it should be uniform in size and nature and size. Okay, then it should be hard and resistant. And number four, it should be such as not to lose more than 5% of its weight after being placed in hydrochloric acid for 24 hours. So these four are your properties of sands that you should use. It should be free from dirt and other impurities. It should be uniform in nature and size. Then it should be hard and resistant. And finally, when you place the sand in hydrochloric acid for 24 hours, then it should not lose more than 5% of its weight. Clear? So next is your, gravel. Okay, about gravel, you see the gravel which may be used below the sand should be hard. Okay, durable, free from impurities, properly rounded, and should have a density of about 1600 kg per meter cube. Gravel of different sizes are usually placed in 3-4 layers, each of 15 to 20 centimeter depth. Okay, depth with the coarsest size and placed in the bottommost layer, and the finest size in the topmost layer. So the gravel which you will be using, it should be, it should be hard. Okay, the first property, it should be hard, durable, and it should be free from impurities. Okay, then again it should be properly rounded also, and it should have a density of about 600 kg per meter cube. You can write all these points in point wise. Okay, here it is written as sentences. You can make it a point wise, these properties. Then also the gravel, with the coarsest size, okay, that is the biggest size in the bottom, it is placed at the bottom. Okay, and the finest size, it is placed at the topmost layer. Okay, so this is your property for your gravel. Here, so these are the properties of your filter materials. Okay, then next let us come to the types of filters that are being used. Okay, if someone asks you what are the types of filters that is used for filtration, then you will say that there are three types of filters. Clear? There are three types of filters. Number one is slow sand filter, then rapid gravity filters, and number three is your pressure filters. But these three filters are also classified on the basis of their rate of filtration. Okay, if someone asks you what is the types of filters based on their rate of filtration, then you will say that number one is your slow sand filter, then rapid sand filter. Again, rapid sand filter, it is divided into two, that is your rapid gravity filters and pressure filters. Clear? So then now we will study about your slow sand, rapid sand, and pressure filters. Pressure filters, it's okay, but generally slow sand filter and rapid sand filters are more important. Okay, and so now let us see what is slow sand filter and rapid sand filters. Okay, so basically, slow sand filters and rapid sand filters, by the name itself, you can guess. Okay, I think you can guess that one will be the rate of filtration will be slow, and the other one, the rate of filtration will be fast, isn't it? So slow sand filters are basically used in small treatment plants, or because it is used in small industries and all those things. Okay, so basically nowadays flows and filters, it has become obsolete. Okay, people generally nowadays it doesn't use flows and filters because of its vast drawbacks. Okay, it has much drawbacks as compared to your rapid gravity filters. Clear? So basically, but one thing you can say that slows and filters, it gives more accurate results, okay, than your rapid gravity filters. Okay, though it has become obsolete nowadays, but generally uh, these slows and filters, they give you more purer water, or you can say more accurate results than your rapid gravity filters. But now you may ask me one question, that ma'am, if slows and filters give more purer water than your rapid gravity filters, so why don't we use slows and filters nowadays? Okay, a question arises. So the thing is that slows and filters, it requires a very vast area for its installation purpose. Okay, it requires a very vast area, and if very vast area is required for slows and filters, that means the more quantity of your filter materials will also be required, isn't it? If the area is large, okay, then you obviously in filters you will be needing the filter materials like sand, gravel, all these things. Yes, so more large area means that there will be more, you will be needing more sand, more gravels. Okay, so what happens? So that becomes a very quite more costly. Okay, that becomes costly. So it is it is and nowadays also you can say that our these towns and cities, they all have become congested. Okay, so there is no there is not much vast area for all these things. So if the this place of installation, or the the these slows and filters would have been small one, then people might have used. But generally also the rate of filtration for your slows and filters is also very slow. Okay, so for because of all these drawbacks, so your rapids and rapid gravity filters are used nowadays. And also one more thing, though in rapid gravity filters, the purification process, it is not as of your slows and filters. But then also you can use rapid gravity filters for one more thing, is that because filtration is not the last step for your treatment process. Yes, because after filtration again there are some treatment processes required to do. So if some impurities are still left in the water, then it can be removed by your next treatment process. Okay, so therefore nowadays rapid gravity filters are much of more importance. Clear? So let you see here, this is a typical, it is a section of a slow sand filter. So basically I will not go through the construction details of slow sand filters. So what you do, you write in your copy about the construction details of slow sand filters and also rapid sand filters. Okay, you write down the constructional details by your own. Everything is given here. You can select the important lines. Okay, like the enclosure tank is here. You draw this diagram. Okay, draw this diagram. Then you write about the constructional details. Everything is given. I have provided this. I guess I have provided to you. Yes, so you write all these things: filter media, base material, okay, inlet and outlet arrangements. Then again about your constructional details about your these rapid gravity filters also you write down. Okay, similarly you write down, here is also one diagram, you see this diagram is there, rapid gravity filter. You draw it nicely and you write down the constructional details. Okay, so slows and filter, you see just now the points that I have explained to you. You see here, what are the uses of slows and filters? Slows and filters are best suited for smaller plants and for purifying waters with low colors, low turbidities, and low bacterial contents. Okay. So, however, because of their smaller rate of filtration, they require huge surface areas and large volume of filtering materials. This makes them costly and uneconomical, especially for treating large scale supplies. They are therefore being replaced by rapid gravity filters at all the major cities and towns. They may, however, be preferred for smaller plants for village supplies or for individual industrial supplies, especially in hotter and underdeveloped countries. Okay, so you write the uses also from here to here. Okay, so okay, let's end our class today here. Let us take the attendance. Okay, we will do the next part in our next class. Okay, Friday. I have given this PDF to you, right? Filtration, coagulation, filtration. I have given, I guess.
Yes, ma'am.
Okay, you write down from there. Huh? You select the important points, then you write down. Are you making the notes or not? Or just you are following the PDF? Don't just okay. Let me bring my pen. Just wait, okay? Yes. So you should, you keep on writing your notes, okay? Try to make one copy and write down the notes. Otherwise, everything you will forget. Today is 23. Okay, roll number one,
Yes, ma'am.
roll number two, three,
Present, ma'am.
four.
Yes, and rule number 2 present.
Okay, roll number four, five, six, seven,
Ma'am,
seven present.
ma'am,
Okay, eight, eight, nine.
Present, ma'am.
Okay, 10, 11,
yes, ma'am.
okay, 12,
Present, ma'am.
okay, 13,
Yes, ma'am.
14, 15, 16, 17, 18, roll number 18, 19,
18.
18 present.
Ma'am, 18.
Okay,
Yes, ma'am.
19, 20,
Ma'am.
okay, 21,
Yes, ma'am.
21 present.
Yes, ma'am.
Okay, 22,
Yes, ma'am.
23,
Yes, ma'am.
24,
Yes, ma'am.
25,
Is it, ma'am?
26.
Ma'am,
Present,
19 is
ma'am.
present, ma'am.
Yes, who said 19? 19 present. Okay, okay,
19, ma'am, 19.
okay, okay, 19 present. And 26 present, right? And 26 present, right?
Present, ma'am.
Okay, 28,
Yes, ma'am.
29, 30,
Present, ma'am.
30, okay, 31, 32,
Present, ma'am.
33,
Yes, ma'am.
34,
Yes, ma'am.
okay, 35, 36, 37, 38, 39, 40,
Yes, ma'am.
41,
Present, ma'am.
42, 43, 44,
Yes, ma'am.
45,